Good morning everyone. As you know, in the previous video we will tell you about what is integer, addition and subtraction of integer, as well as comparing of integer. In this video I will tell you about properties of integers. Properties of addition and subtraction of integers. The first property of addition and subtraction of integer are closure property. For any two integers a and b, a plus b is also an integer. Example, minus 3 plus 3, which is equal to minus 2. Therefore, we say that integers are closed under addition, which means if an integer is added to another integer, we always get an integer as the answer. For any two integers a and b, a minus b is also an integer. Example, minus 5 minus 3 equal to minus 8. Therefore, we say that integers are closed under subtraction. It means if we are subtracting one integer from another integer, the result is always be an integer. With the help of example of closure property, we will tell you about this property. As you know, what the closure property has says, if sum of two integer is also a integer. So here in the first example I will take you two integers, or you can say we are taking two positive integers. So first positive integer is 5 and second is 4. So 5 plus 4, which is equal to 9, and 9, it is also an integer. In the second example, I will take one positive and one negative integer. So if we are finding addition of one positive and another negative integer, so we will again get an negative integer in the answer. And for third example, if we are taking both the integer of negative integer, still their sum is also a negative integer. Hence, we can say that the sum of two integers is always an integer. Now, example of subtractions. In the first example, I will take two positive integers and find their subtraction. So, what we will see in students, if we are subtracting 2 minus 5, we will get answer minus 3, which is also a integer. Now, come to second example. Here, first is negative integer and second is positive integers. If we are subtracting these two integers, we will also get the answer in integer. In the third example, we will take both the integer is negative integer, and if we are subtracting that, so we will again get the answer as a integer. Commutative property. This property tells us that the sum of two integers remain the same even if the order of integer is changed. If a and b are two integers, then a plus b is equal to b plus a. Example, minus 2 plus 3 equal to 3 plus minus 2. It means if we are changing the order of integer, it does not affect the result. Subtraction. The subtraction of two integers is not commutative. If a and b are two integers, then a minus b does not equal to b minus a. Some example of commutative law of addition. First example, you can see the student, we will take one negative integer and one positive integer and find their sum. So minus 4 plus 9, which is equal to 5. And if we are reverse their order, Means first we will write that positive integer 9 and after that we will write negative integer, so which is equal to again 5 a integer. It means if we are change the order of the integer, it will be not affect the result. Come to the second example. In that we will take both the integers is negative integer. So first is minus 5 and second is minus 8. If we are adding minus 5 and minus 8, we will get the answer minus 13. And if we will reverse the order of that, we will get the same answer. Hence, we observe that if a and b are two integers, then a plus b equal to b plus a. Associative property. This property tells us that we can group integers in a sum in any way we want and still get the same answer. Addition is associative for integers. In general, a plus b plus c equal to a plus b plus c. Example, 2 plus 3 plus 4 equal to 2 plus 3 plus 4, which is equal to 9. In that we can say that this property follow the concept of grouping. So when the grouping is changed, their result does not change. Subtraction. The subtraction of integer is not associative. In general, a minus b minus c does not equal to a minus b minus c. It means associative property does not exist for subtraction. Now here's some example of associative law of addition. In this we will take first example. In that example I will consider few integers. The all integers are positive integers. So first is 7, second is 9 and third is 6. And we will put all these number in that identity. So the associative law has said a plus b inside bracket plus c, which is equal to a plus b plus c. So 7 plus 9 plus 6, which is equal to 16 plus 6 equal to 22. And 7 plus inside bracket 9 plus 6 equal to 7 plus 15 equal to 22. It means if we are change the grouping of the integers, it will not affect the result. Here we have another example. In that example, I will consider two negative integers and one is positive integer and put the value. So minus 6 plus minus 8 written one bracket plus 5 equal to minus 14 plus 5 equal to 9. And second time minus 6 plus inside the bracket minus 8 plus 5 equal to minus 6 plus minus 3 equal to minus 9. So we observe that if a and b and c are three integers, then a plus b plus c equal to a plus b plus c. Now additive identity property. There exists a unique number 0 such that 0 preserve identities under additions. A plus 0 equal to a and 0 plus a equal to a. In other words, you can say that adding 0 to a number does not change its value. It means if we are adding 0 to any integer, it does not change the value or identity. Means if we are adding any integer with 0, the answer should remain that particular integer. Now inverse property. Inverse property of addition is a plus minus a equal to 0. The additive inverse of a number is the number that has the same absolute value but the opposite sign. The sum of a real number and its additive inverse is always equal to 0. It means if we are taking any integer or you can say if you are taking any positive integer, so the inverse of that particular integer is negative integer. Or you can say if you are taking any negative integer, so the additive inverse of that integer is positive integer, and the sum of a real number and its additive inverse is always equal to 0. Example of additive identity. Here I will take one positive integer and add with 0. So the answer is same, a integer. Or you can say that if you are adding 9 plus 0 or 0 plus 9, it will become a same real number. In the second example, we will take a negative integer which is minus 6. So we will add minus 6 plus 0 equal to 0 plus minus 6, which is equal to minus 6. Hence 0 is called the additive identity for integers, which means if we are adding 0 with any integer, the answer should be that particular integer. Example of additive inverse. As you know, in the additive inverse, if a number is a positive integer, so their additive inverse is a negative integer. So in the first example, I will take 5 and the additive inverse of 5 is minus 5. And as you know, the sum of real number and additive inverse become 0. So 5 plus minus 5 equal to minus 5 plus 5, which is equal to 0. Here one more example is there, minus 3 and their additive inverse is plus 3. So minus 3 plus 3 equal to plus 3 plus minus 3, which is equal to 0. Through this chart, I will give you a small recap of all the properties. The first property is closure property, which is say for addition is a plus b belongs to z, and for subtraction a minus b belongs to z. Commutative property. For addition, a plus b equal to b plus a, and for subtraction a minus b does not equal to b minus a. Associative property. For addition, a plus b plus c equal to a plus b plus c. For subtraction, a minus b minus c, which is not equal to a minus b minus c. Distributive property. A into b plus c equal to ab plus ac. And for subtraction, a into b minus c, which is equal to ab minus ac. Properties of multiplication and division. The first property of multiplication and division is closure property. The product of two integers is always an integer such that if a and b are two integers, the product of a and b is also an integer, which is a into b equal to c, where c is also an integer, which means if we are finding the product of two integers, so their product is also be a integer. So here c is also an integer. Example of closure property of multiplication. In first example, we will multiply 7 into 5, which is equal to 35, where 35 is also an integer. Means product of two integer is also be an integer. In the second example, we will take minus 8 into 4, which is equal to minus 32, which is also an integer. In the third example, we will take 9 into minus 6, which is equal to 54, which is an integer. In the fourth example, we will take minus 8 into minus 7 equal to 56. Commutative property of multiplication. The product of a group of number is the same regardless of the order in which the numbers are arranged. Example, 3 into 2 is equal to 2 into 3, which means if we will change the order of the integer, so the result should be same. Same as in the second example, 24 into 11, which is equal to 11 into 24. Now example of commutative law of multiplication. Here we will take two integers. First is 5 and another is minus 8 to minus 40. And if we will reverse the order of these integers, so minus 8 into 5, which is equal to minus 40, such that 5 into minus 8 is equal to minus 8 into 5. The second example, we will take minus 9 and minus 7. So minus 9 into minus 7, which is equal to 63. If we will reverse the order of that, so minus 7 into minus 9, which is equal to 63. That minus 9 into minus 7 equal to minus 7 into minus 9. Next is associative property. You can group factors in different ways and you will get the same exact product. 5 into 2 into 8 equal to 80. 5 into inside bracket 2 into 8 is equal to 80. It means grouping is not necessary for multiplication. In other words, the grouping in multiplication does not matter. Means if we are changing the groups, so there will be the product should be same. Example of associative law for multiplication. Here in the first example, we will consider 3, minus 5 and minus 8. So we have 3 into minus 5 into minus 8, which is equal to minus 15 into minus 8, which is equal to 120. And 3 into minus 5 into minus 8, which is equal to 3 into 40, which is equal to 120. Such that 3 into minus 5 into minus 8 equal to 3 into minus 5 into minus 8. Now second example. In the second example, we will take all the negative integers, which are minus 8, minus 6 and minus 5. We have minus 8 into minus 6 to minus 5 equal to 48 into minus 5, which is equal to minus 240. And minus 8 into minus 6 into minus 5, which is equal to minus 8 into 30, which is equal to minus 20, such that minus 8 into minus 6 into 5 equal to minus 8 into minus 6 into minus 5. It means the grouping in multiplication does not matter. Distributive property of multiplication over addition. The distributive property of multiplication over addition states that A into B plus C is equal to A into B plus B into C, or A inside bracket B plus C equal to AB plus BC. Multiplying a number by a sum B plus C will give you the same value as multiplying A by both B and C and then adding the products. If A, B and C are three integers, then A into inside bracket B plus C equal to A into B plus A into C. This is the distributive property over addition. Example of distributive law of multiplication over addition. Here we will consider three integers like 5, minus 6 and minus 8. So 5 into minus 6 plus minus 8 equal to 5 into minus 14, which is equal to minus 70, and 5 into minus 6 plus 5 into minus 8, which is equal to minus 30 plus minus 40 equal to minus 70, such that 5 into minus 6 plus plus minus 8 equal to 5 into minus 6 plus 5 into minus 8. Multiplicative identity property. For any number a into 1 is equal to 1 into a is equal to a. The product of any number and 1 is equal to that number. The number 1 is called the multiplicative identity. Example, if a is equal to 6, then 6 into 1 is equal to 1 into 6, which is equal to 6. It means if we are having any integer a which is multiplied by 1, so the product is the same integer a. Inverse property for multiplication. Inverse property for multiplication is state that product of any number and its multiplicative inverse or its reciprocal is 1. Example of multiplicative identity property. First example is 7 into 1, which is equal to 7. Second, minus 3 into 1 is equal to minus 3. Here you can see in both the example, if we are multiple any integer by 1, the product is the same integer, and if we will multiply 0 by 1 or 0 will be multiplied by 1, so answer should be remain same, it will be 0. Example of inverse property for multiplication. 5 into minus 1, which is equal to minus 5, or you can write like that, minus 5 into 5, which is equal to minus 5. So inverse of 5 is minus 5. Through this chart I will give you a small recap of properties of multiplication and division of integers. First is closure property. For multiplication, a into b belongs to z. For division, a divided by b does not belongs to z. It means closure property is only applicable for multiplication. Next, commutative property. Here for multiplication, a into b is equal to b into a. For divide, a divide b does not equal to b divide a. It means commutative property is exist only for multiplication. Associative property. For multiplication, a into b into c, which is equal to a into b into c. For division, a divided by b divided by c does not equal to a divided by b divided by c. It means associative property is exist for multiplication. Next, distributive property is not applicable for both. Now I will have some classwork questions. First question is find the additive inverse. So here first part is minus 83. So as we all know what the additive property says, the sum of an integer and its opposite is 0. So minus 83 of its opposite is plus 83. So we can write like that, 83 plus opposite of minus 83, which is equal to 0. So we can say that additive inverse of minus 83 is plus 83. Come to the second question. It is 256. So the opposite of 256 is minus 256. So apply additive inverse. We will write 256 plus minus 256, which is become 0. So the additive inverse of plus 256 is minus 256. Now come to the second question. If a equal to minus 8, b equal to minus 7, c equal to 6, so verify that by using associative law of addition. So student, as we know that what the additive law of addition says, a plus B inside bracket plus C equal to A plus inside bracket B plus C. So what we will do, we will put all the values of A, B and C in this equation and prove that left hand side equal to right hand side. So first we will put the values. So A is equal to minus 8 plus B is equal to minus 7 and C is equal to plus 6 equal to, again A is equal to minus 8 plus B is equal to minus 7 plus C is equal to 6. Now we will put all the values. Now we will solve that. See, minus 8 plus minus become minus 7. We will write inside bracket plus 6 which is equal to minus 8 plus minus 7 plus 6. It will be become minus minus plus, so 8 plus 7 is 15, but we will consider minus sign because 8 is greater than to 7 plus 6 equal to minus 8 plus, here plus minus minus, so it will be become minus 1. So minus 15 plus 6 equal to minus 8 plus minus minus 1. Here plus minus is minus, so 15 minus 6 is 9, but 15 is greater than 6, so we will consider the sign of 15. It will be become minus 9 equal to, here minus minus become plus, so 8 plus 1 equal to 9, but sign we will take in the greatest number which is 8. Here it will be a minus sign. So student, we can see that their left hand side is equal to right hand side. So yes, it is verified the associative law of addition. Come to the third question. It will be the simplify by using distributive law. Student, as you know what the distributive law has says, A into inside bracket B plus C equal to A into B and plus B into C. So here in this question, A is minus 8, B is 9 and C equal to 7. We will put this value in this formula. So here minus 8 into B equal to 9 plus C is equal to 7, which is equal to minus 8 into 9 plus 7 which is equal to 16 equal to 16 into 8 is 128 and sign should be minus. So what the conclusion of using this law is that it will be made a simple solution of particular question. Now come to the second question. We will solve as it is, whatever we are solving the first question. So again we will write the law A into B plus C which is equal to A into B plus A into C. In this question our A is 20, B is minus 16 and C is 14. So we will apply in this property. A is 20 into B is minus 16 plus C is 14 which is equal to 20 into minus 2 which is equal to minus 40. Now student, I will give you some homework question related to these properties. You can do the practice of these questions at home. Student, keep calm and stay home. Thank you.